In question 9, I'm making use of the remainder theorem, substituting in the factor, the testing factor, in order to work out the remainder. Now in the first instance, plugging in 1, that will give me -5. So therefore the remainder is equal to -5. I'm not required to do it, the -5x minus 1, as my remainder there if I want to write in that format. Next one, I'm checking x plus 1, which means I'm substituting in -1. Which gives me 2 as my remainder there. Working through C, I'm dividing in x minus 4, substituting in 4. So -128 plus 2 16s, 32, take 4, take 1. And yep, I did use my calculator. That will give me a remainder of -101. Now in part D, you're dividing by 2x plus 1 or substituting in -1/2. So -1/8 plus 1/4 minus 1/2 minus 10 will be the order of the day there. Converting everything I need to into eighths. You can see there -10 and 3/8 will be my answer. So a little bit more care. There's no problems at this stage using your calculator in the fraction mode to check these as you go. Now moving on, with 27x cubed minus 9x squared minus 9x plus 2 divided by 3x minus 2, I've substituted in 2/3, and to cut a very long story short, when I plug it into my calculator, I've found 0. So what I can also state is 3x minus 2 is a factor. And lastly, 9f, we're testing x minus 2, or finding the remainder there. So I'm plugging in 2 using the factor theorem. So it gives me 64 less 40 plus 8 minus 14 plus 8 gives me a total of 26 as my remainder. Now please make sure that you can do these, and also that you can, when the remainder is 0, identify you've got a factor, and then the key point there will be to, by trial and error, find the quadratic for the cubic quotient.